I'm not going to sit here and pretend React Native's always been perfect. There are some skeletons in that closet, but thankfully, the Facebook team recognizes it, and they've just rebuilt the vast majority of the React Native core to make it significantly faster, significantly more scalable, and most importantly, way easier to plug native code into. I want to go over all of this because these changes are huge and fundamentally shift the way we should think about and use React Native. So let's dive in to everything the React team themselves have to say about the new architecture. Since 2018, the React Native team has been redesigning the core internals of React Native to enable developers to create higher quality experiences. As of 2024, this version of React Native has been proven at scale and powers production apps by Meta. The term new architecture refers to both the new framework architecture and the work to bring it to the open source world. I like they're using new architecture here because with server components, we don't have a good word that encompasses everything, because server components are like a way to render components on the server and a way to interface them with client components. But then there's also server actions, and there's also streaming and the new suspense stuff. There's a lot of these new concepts that all fall together under one umbrella that there's no term for. Where in the React Native world, they just straight up said, oh, this is the new architecture. It has like 15 things in it, but this is all encompassed under the new architecture. I wish we had a term like this for the server side, but honestly, generally speaking, the React Native team has been way better at communicating, both with their like immediate dedicated users. Like the React Native team talks to a lot of the companies that use React Native, much more so than the React Web team. But as such, they're much more familiar with how people are understanding these things as they talk about them. So a lot of this communication gets cleaned up a ton before it goes public. And it's cool to see I know it's such a small thing, but the use of a term to describe these changes as one thing is really, really nice. And I wish they did this for React itself. Anyways, the new architecture has been available for experimental opt-in as of React Native 0.68, which by the way, they're on 0.73, so it's been a while. And it has continued improvements in every subsequent release. The team is now working to make this the default experience for the React Native open source ecosystem. Cool to see so many versions since then of them really refining it. Like this original announcement was in 2022. Oh, good old Lorenzo. He's a legend. As I said, like React Native isn't just within Meta the same way like React is. Microsoft is an active contributor to React Native. Amazon has been helping a ton with things like the static Hermes compiler. There are lots of companies that aren't Meta themselves that are interested in making sure React Native succeeds. Shopify is another huge one. Shopify's put so much effort into making React Native go from good to great. So this is not just some quick thing they put out. This is years of effort, possibly like half a decade plus of effort, and 2+ years since it initially was released. Now we're seeing them working finally towards making it a default. Lots of effort, lots of dogfooding, lots of time put into this. If you're wondering how I know so much about these inner workings, it's actually pretty simple. It was one event I went to last year, Chain React, and I'm thankful to say they're actually sponsoring this video right now, at least this bit, so I can tell you all about why Chain React is hype. Last year, I was blown away. I got to keynote the event. I got to talk with all sorts of cool people. The food was incredible. Obviously, Chain React's happening again this year from July 17th to 19th, and that first day, the 17th, is dedicated to workshops hosted by Infinite Red, Expo, and even Microsoft helping out too. But honestly, I'm even more excited for the talks this year. We're going to hear from everybody from Microsoft to Meta to Amazon to Shopify to Coinbase and so many more, talking about the new architecture for React Native, the crazy things they've done to scale their code bases, and just diving deep on all the nerdy details. If you enter the code Theo, you get $50 off, and I get paid. So if you can, enter that discount code, go buy these tickets, or better, convince your company to buy them for you if you work at a company that's interested in or using React Native. And if you're not interested in React Native, there's a code for you too. Enter Swift at checkout instead, and you'll see there's a new option that costs twice as much because building your apps in Swift takes twice as long. Back to the video. But why? Why make a new architecture in the first place? After many years of building with React Native, the team identified a set of limitations that prevented developers from crafting certain experiences with high polish. These limitations were fundamental to the existing design of the framework, so the new architecture started as an investment in the future of React Native. The new architecture unlocks capabilities and improvements that were impossible in the legacy architectures. Interesting. Nobody's better at shitting on React Native than the React Native team, and it's nice seeing them do it and calling out the fundamental limitations that prevent the levels of polish that they wanted people to be able to achieve, especially when you consider that React Native isn't just targeting mobile anymore. It's targeting desktop, it's targeting VR, it's targeting consoles. Like, so much of the Xbox interface runs on React Native. It's crazy. They need these things to not just work well, but bind well to native platforms. Synchronous layouts and effects. Building adaptive UI experiences often requires measuring the size and position of your views and adjusting the layout. Today, you would use the OnLayout event to get the layout information of a view and make any adjustments. However, state updates within the OnLayout callback may apply after painting the previous render. This means that users may see intermediate states or visual jumps between rendering the initial layout and responding to the layout measurements. Think of this as like, I'm resizing my window. The browser does a great job of moving things there because React isn't running when I do that. When I resize this window, the React code isn't changing anything. The React's already run and painted the DOM. It's CSS that's doing the shifting. On mobile, we don't have CSS. So when your viewport changes for any of many reasons, especially when you're talking about these new environments like VR or game consoles, those views might change in size in all sorts of different ways. And if you're writing React code to change that UI and change the view as the viewport changes, that's going to suck. That's going to be really slow to have React updating every frame to try and render the right content. And it's not going to know until the window changes. So yeah, makes a lot of sense. That's the type of thing they want to target here. With the new architecture, we can avoid this issue entirely with synchronous access to layout information and properly scheduled updates such that no intermediate state is visible to users. Let's take a look at this example. Tooltips, everyone's favorite. Measuring and placing a tooltip above a view allows us to showcase what synchronous rendering unlocks. The tooltip needs to know the position of its target view to determine where it should render. In the current architecture, we use OnLayout to get the measurement of the view and then update the position of the tooltip based on where the view is. So this is even just like scrolling. It has to call this in order to put the thing in the right place. So here we see function view with tooltip. Const onLayout equals React use callback, target ref, and then this onLayout call for the view. This is what's called when the view changes in any way. And in order for this to work, they grab the target ref from this change, and then they set the rectangle's position to be the new position based on what they're grabbing from the window here. And this has to run on every frame in React. That sucks. With the new architecture, we can use layout effect to synchronously measure and apply layout updates in a single commit and avoid the visual jump entirely. So this is still running within React. The difference is that layout effect runs before the render instead of after. So this will move the tooltip before the user even sees the change. This will effectively block the new frame from displaying, which prevents the jank of the tooltip moving after you scroll. And if we see the example here, when this moves, the tooltip moves afterwards. In the new version, it just moves all at once because the tooltip's moving is blocking the rest of the view. Sounds bad to block, but when you make these types of things synchronous, you prevent a ton of potential additional issues. Somebody said, why can't you debounce in chat? And you can debounce, but then you're going to have the tooltip moving at a different rate from the rest of the view. So if you're scrolling up in the view, the tooltip's going to stutter based on how much you set the debounce for. You can't debounce UI in that way. You cannot debounce animations, scrolls, all those types of things in that way. You can debounce like a fetch call, but you can't debounce this. So I just saw the codebase is 26% Java. Yeah, because React Native targets Android. And in order to target a platform, you have to write a lot of code for that platform. React Native writes a really good Android app in Java and a really good iOS app in Objective-C. They're playing with Swift and they're playing with Kotlin, but they focus on the technologies that are the most stable that they've been building on forever because I, as a React Native developer, I'm not writing Java. So that's synchronous. What about concurrent? Because blocking is great, but parallel is greater. The new architecture supports concurrent rendering and features that have shipped in React 18 and beyond. You can now use features like suspense for data fetching, transitions, and other new React APIs in your React Native codebase, further conforming codebases and concepts between web and native React development. The concurrent renderer also brings out-of-the-box improvements like automatic batching, which reduces re-renders in React. In this example, a slider specifies how many tiles to render. Dragging the slider from 0 to 1,000 will fire off a quick succession of state updates and re-renders. In comparing the renderers for the same code, you can visually notice the renderer performance provides a smoother UI, with less intermediate UI updates. You can see here with the old and new, when you scroll around, this happens almost immediately, where this one fills in slowly as all the new updates render. I was actually building like a shared music listening experience in React Native a while back that had like people moving and such in it. And I had to defer most of that animation over to be in like React Native reanimated and not within the React Native JavaScript side itself because of how much these types of things hurt your performance because they weren't parallel. So this is really cool to see. Quick look at the code for the sake of it. Yeah, we have all our colors, view, value is a number. And then for all of these, we add a view in the views.push. And then we render them all. And this is the same code used for both. You don't even have to change the code. It just runs better. There's nothing better than you install an update and your existing code just works faster. That's so cool. I will say React Native version upgrades are not the smoothest thing in the world. But if you can get to the new version, this is huge. New concurrent features like transitions give you the power to express the priority of UI updates. This is also really big because some UI updates might be more important than others. And it's not easy to tell React, hey, don't do this until this is done. And now it's just built in. Marking an update as lower priority tells React it can interrupt rendering in order to process things that are higher priority. Let's take a look at an example here. This is using the tile slider again. Is pending start transition. View text renderer, animation is pending. slider on value change, start transition. So because the value change now triggers a transition, React knows, okay, if a transition is happening and a new update calls that calls the same transition, I can interrupt that. And here, yep, tiles generate tile views. These all take higher priority because they're not wrapped in a transition. So you'll notice with the frequent updates in a transition, React renders fewer intermediate states because it bails out of the rendering the state as soon as it becomes stale. That's the big difference. If you don't have a transition for this, it won't process the next update until it's finished this one. When you wrap it in a transition, you are basically saying, hey, React, by the way, if this gets called again, dump whatever the fuck you were doing before, use this new state instead, which is really nice to explicitly tell React, hey, you can skip that step, by the way. Fast JavaScript and native interfacing. This is honestly what I thought of when I thought of the new architecture, and I'm happy they called it at the top that it's a whole umbrella term for a bunch of things, because this was what I was thinking of. The new architecture removes the asynchronous bridge between JavaScript and native and replaces it with a JavaScript interface. The JSI is huge. JSI is an interface that allows JS to hold a reference to a C++ object and vice versa. Do you guys know how nuts this is? You can't even get JavaScript to hold a reference to a JavaScript object. Having the ability to call a C, like have an object in C++ that is shared memory with JS and have that binding native without an async layer transitioning things over the wire, this is huge. This changes everything. As I say, with the memory reference, you can directly invocate methods without serialization costs. Nuts. So cool. Just like one of many dumb examples, the code for chat on Twitch chat, specifically for the colors, is significantly more complex than one would like to imagine. One of the important parts of the Twitch colors is that anyone can pick whatever color they want. The more important part is that in dark mode or light mode or whatever modes you're using, the contrast is high enough for the names to be readable. Previously, that wasn't the case, and a common troll people would do is they would change their name color to be really close to the background color of Twitch so you couldn't see their name. In order to fix that, Twitch changed the default chat mode. And when I say Twitch did this, I mean one particularly dedicated engineer worked her ass off to fix the chat colors on Twitch to make them readable and accessible. See this readable color switch? If I turn that off, I'd have to refresh. Seems like nobody's colors are off enough to be hard to read. But if somebody had a dark enough color and I turned this switch off, it would be very hard to read their name. The math they did to make that color thing work is why I'm bringing it up, though, because they wanted to make sure the colors matched across all platforms. So I need to make sure on desktop, on iOS, and on Android that the colors are the same. And any math I'm using to transform the color based on your color schema needs to be consistent. The only language that they could find at the time that let them apply the math to transform the colors consistently was C++. So the code that actually takes the chat color and transitions it to the color that looks right for your display, regardless of your platform, is the same code written in C++. As insane as that sounds, and believe me, I was weirded out when I first heard it, that justification of we want the colors to match everywhere, and the only way we can guarantee that is a language that we implemented the math of. That was crazy, and I have a ton of respect for them for doing that. Writing the bindings to get that C++ code into the Android app was not fun. They did it, but it wasn't fun. Now, that's just a feature built into React Native. You can just call a C++ object or a C++ function, whatever you want, and it just works. So as much as I don't want to write C++ code, the idea that someone could write some really complex math in C++ and I just have access to it in React Native, that's crazy. And I love that. Let's see how they actually use this though, because as cool as it sounds, I want to see their recommendations. JSI enables the Vision camera, a popular camera library for React Native, and it can now process frames in real time. Typical frame buffers are 10 megabytes, which amounts to roughly a gig of data per second. This might sound insane, but as someone who shoots in 4K, the stream that I'm recording right now is going to be 6 to 7 hours. That's going to be about 500 gigabytes of content. These sizes make a lot of sense, especially when you're not compressing. Like my camera footage is compressed. If that was uncompressed, each frame is insane. And if you want to know more about frame compression, I have a whole video about how H.264 works coming very soon, if it's not out already. YouTube search Theo H.264, and hopefully a video comes out by the time this is out. Anyways, that's a shitload of data, and when you're getting it straight out of the frame buffer, it's going to be full size. Depending on the frame rate, especially, like it gets worse if you do like 60 or 120 or any other frame rates or increase the resolution. There's the data you get from the frame buffer from the camera is nuts. I'm trying my best to not do a long rant about cameras and multi-plat stuff because I could do an hour-long tangent about the Snapchat camera on Android. What I will say is that the camera bindings that exist for these platforms, like in the case of Android, the Android camera SDK was so atrocious and so slow and inconsistent that in order for the Snapchat team to add a good experience where you could do like the sliding to and from the camera part, they didn't use the camera SDK. They used the camera viewfinder SDK, which was meant to be used to give you like a little preview of what the camera was doing that didn't require pulling shutter for every single frame. And it looked awful. And rather than when you click the picture button, telling the camera SDK, hey, take a picture and send it back to me, they would literally take a screenshot of the like viewfinder SDK. Hilarious. That's why Android Snapchat and also Android Instagram for a long time looked so shit, because the camera SDK on Android was so shit, it was the only option they had. But now that we have native bindings here and awesome stuff like Vision Camera, as well as the Android SDK getting a little bit more viable, we don't have as many of those problems anymore. I think Snapchat might still be the case like that on certain phones. I think the Pixel line generally has better SDK support, but I could literally rant about that forever. I'm so sorry for the tangent. Back to React Native. In comparison with the serialization costs of the bridge, JSI handles that amount of interfacing data with ease. JSI can expose other complex instance-based types, such as databases, images, audio samples, etc. Why would you ever want to expose a database like this? I can think of a lot of reasons. One of my favorites that I pulled up on stream earlier, Project Lightspeed, which, if you're not familiar, was the rewrite of the Facebook Messenger app, rewritten in, of all things, SQLite. Yes, the UI is powered by dynamic SQLite templates because, much like C++, SQLite's one of those tools that is basically identical and really performant on literally every single platform. So if they write everything in the SQLite binding, it works everywhere. And it's crazy how these other things we've invented to try and make truly multi-platform code bases, experiences, and consistency, like C++ color math or craziness here with SQLite as your UI layer. These are all the things companies like Facebook invented in hopes of making things consistent across platforms. Now, we just have it built into React Native. So if you want to use something like databases in your React Native code performantly with a native database running in C++ land, just built in now. So cool. JSI adoption in the new architecture removes this class of serialization work from all native JavaScript interop. This includes initializing and re-rendering native core components like a view or a text element. This is huge. Not having to go through the async layer just to update a text component, huge. You can read more about our investigation into rendering performance in the new architecture and also the improved benchmarks that they measured. A 1500 view component went from 282 to 258, so slightly faster. 5000, still just slightly faster. This is also on a Pixel 4. If we look at an iPhone 12, though, we see a much bigger jump here. Because, oh God, I'm going to get in trouble for this one. Since Android's already written in a pretty big abstraction, JavaScript's not a massive cost on top. And the Pixel 4, when did the Pixel 4 come out? 2019, iPhone 12 release date. Okay, the iPhone 12's a year newer. But like a 1 year difference between these phones, even like the old React Native architecture was twice as fast as the new one. Like Android's just a little rough. Java's not the right thing to write your operating system in. And that's why we're like the base tier performance possible on Android is shit because it's so gimped by architectural decisions. I'm not saying Android itself is bad and terrible and you shouldn't ever use it. I'm just saying it's fundamentally flawed and cannot ever perform as well as iOS. Just cannot do it due to the way they abstracted the language and had to reinvent Java to make it perform at all. The difference here is roughly the same as here. It's about like 22-ish, 24 milliseconds. Here it's almost identical difference. The key is that the base potential performance on iOS is so much higher that the percentage difference is bigger. So yeah, Android slow, hopefully not news to most of you. Flame me in the comments. I know you're going to. But yeah, what happens here is like... No, I'm not going to say the Flutter word. I'm not going to say the only reason Flutter is acceptable is because Android is already so slow that the abstraction doesn't matter. I'm not going to go on that tangent. I'm just going to say that iOS apps and iOS users have a certain expectation of performance on their device. And that expectation comes from how fast iOS can be at doing all sorts of crazy shit. And what I'm excited about when I look here is that React Native now performs significantly closer to what iOS users expect from their applications. This is really cool to see. They call out a section where you can go learn more, a bunch of updates to the documentation as well as the working group. I love that they've been doing these working groups too, where there's like a place where people who are deep in the weeds for these new things can go and talk and play with them. I know like Nikhil was deep in the working group for server component stuff and ended up building the tools you need to make your own React server component framework. I know that somebody like Daishi, who built Waku and also built Jodai and maintains Sustan and a bunch of other stuff, he's part of the React working group as well in order to talk about these new things. It's really cool seeing the meta React communities as a whole embracing community in this way. It's been a huge shift from not just how I think of React, but how I think of web frameworks as a whole. It's really cool to see. So what can we actually expect from enabling this new architecture? Well, the new architecture architecture enables these features and improvements, enabling the new architecture for your app or library may not immediately improve the performance or the user experience. For example, your code may need some refactoring to leverage new capabilities, like the synchronous layout effects or concurrent features. Although JSI will minimize this overhead between the JS and native memory, data serialization may not have been a bottleneck for your app's performance in the first place. This is also an important thing. Like, if you're just rendering views with a bunch of stuff in them, serialization between the native layer and the React Native layer probably isn't the problem that you're having. And there's a lot of other things you can do to improve performance for that stuff too, like flash list, which I don't talk about enough. Flash list is a new list component written to make your lists that are really long with a ton of data perform much better in React Native. And it is a huge win. The FPS you can get on a giant list with flash list versus the built-in flat list in React Native is hilarious. In the UI thread, it's up to 5x, but in the JS thread, 10x plus. And this is on an Android Moto G10, so they're testing it in like the worst possible scenario too. This is such a phenomenal update, and I'm so happy that this exists. Also, a big part of how I learned about this was hanging out with the guy who built it when I was at Chain React. And I watched one of my favorite talks I've ever seen. Yes, this talk, Default to Performance, from Chain React last year, was incredible. Phenomenal talk about how performance happened at Shopify with React Native and all the things they did to make it possible. And it has 100 views. That's insulting. I'm going to put a link to this in the description of the video so you can check it out if you haven't and you're curious, because it was such a good talk. And before someone says it, well, if you wrote that code in native, it wouldn't be slow. Let me tell you something. See this button here? This is for the library of all my downloads in Arc, which was written in Swift. I don't know if you guys can see that there. That is some noticeable lag. And it was way worse before. They've had to rewrite this component like 5 times in order to make this list work at all. And it still chugs when I scroll. It is hilarious how bad long lists perform in Swift by default without you building your own list primitive. So yeah, write it in native, except the native code sucks too. Flash list fixed all of that for all different platforms that you might target. They did the hard Swift code and the hard Java Android code so that you can just write nice, basic, boring React code. Like, this is how you render a list that performs well in React Native now. That's it. Should be that easy. Should always have been that easy. One more important call out from Evan here, very worth pointing out, is that the new architecture is actually required for building server components in React Native. Things like use, suspense, and use transition, they just don't work without the new architecture and how it changes the threading model within React Native, which is huge and very important, especially now that I'm predicting over the next couple years, React Native devs are going to slowly become full stack the same way React Web devs are becoming full stack with tools like Next. I already have a video talking about mobile devs hate servers. Expo wants to fix that, where Expo is working very hard to slowly push people in the direction of React Native and server code and the relationship between those things. Anyways, enabling the new architecture in your app or library is opting into the future of React Native. I like that. Nice call out. And I personally like opting into the new future when I have the opportunity to experiment with and really use these new things. But over 2 years of release later and a ton of iteration and dogfooding, this isn't that experimental anymore. The team's actively researching and developing new capabilities that the new architecture unlocks. For example, web alignment is an active area of exploration at Meta that will ship to the React Native open source ecosystem. I've talked about this a little bit, especially like the conformance stuff. If you guys have seen my video on React's next big change is the React strict DOM. They're not going to force everyone to use strict DOM. They might not even go with it long term. But the goal of strict DOM was to make it so you could write code that is reusable as like one code base on iOS, Android, other platforms, and web by abstracting enough of the primitives that it can be applied correctly in these different platforms. Because there's no such thing as a div on Android or iOS, unless you render a web view, which then sucks. So all of these types of things are work in order to make fully shareable and repurposable building blocks for React across all of the places you can use React code. This includes the changes to the event loop model that they're working on, node and layout APIs that are making things more consistent, DOM traversal, stuff like that, the layout conformance stuff, and the chaos that is Yoga. If you're not familiar with Yoga, it's TLDR, it's how things like Flexbox work in native. Really, really cool stuff. I've even seen people using Yoga outside of React Native, but like Flexbox and Gap and all these crazy behaviors that we expect from the web only work in React Native because Yoga is built to make a flexible, pun intended, UI layer. So, enough about what it is. Should we actually use this new architecture today? Well, today, the new architecture is considered experimental still, and we continue to refine backwards compatibility for a better adoption experience. The team plans to enable the new architecture by default in an upcoming React Native release by the end of 2024. Our guidance is as follows. For most production apps, we do not recommend enabling the new architecture today. Waiting for the official release will offer the best experience. Imagine if they said this with something like Next.js when it came out. I don't know how much stress this would have avoided, but it would have been some amount. It would also have hampered the hype, which might not have been worth it. But React Native is not trying to hype us up here. They're not trying to shout from the rooftops, everyone use this now. They're trying to show us what the future looks like. And I like that they're calling out that you shouldn't adopt this for real production apps, or at least they're not recommending it. I know I'm going to be using this if I build a React Native app because that's just who I am as a person, but they're giving an easy out to people who aren't sure. Because I know a lot of people don't want to ship Pages Router on Next today because App Router is the hot new thing. It's fine to ship Pages Router. It's still more stable. It still has great support from everything, and they're not going to get rid of it anytime soon. The old architecture in React Native is the same deal, but they're communicated differently. This also calls out that if you maintain a React Native library, they do recommend enabling it and verifying that your use cases are covered. You can find instructions to that here. This is also really cool because I know a lot of the complaints around server components have been the lack of resources for library maintainers in order to adopt these things. Cool. They have a whole section here, a place to chat about third-party libraries and their migration story to the new architecture. This is the React Working Group and React Native New Architecture repo. And here's the community for discussion where people can talk about these things. Really cool to see this type of opportunity for anyone that's building React Native tools and technologies to communicate with the team. Whew. What a read. I love talking about React Native. I need more opportunities to ship it, but haven't had too many as of late, just building everything for the web. But when all this stuff ships, it'll be easier than ever to share that web code with mobile code and make a great experience for everyone. Curious what you guys think about the new architecture. Is this going to finally shut up the Flutter people, or is this nothing interesting to you at all? Let me know in the comments. Until next time, peace nerds.